Hello. Today we're going to be solving equations with variables on both sides after we're able to derive an equation from a story or from a model. Our first question says, A1 plumbing service charges $35 per hour plus a $25 travel charge for a service call. Good Guys Plumbing Repair charges $40 per hour for a service call with no travel charge. How long must a service call be for the two companies to charge the same amount? Well, first we have to determine what we're going to use to mathematically represent the cost of a service. So we're going to have A1 on one side of our equation, and on the other side we're going to have Good Guys. So A1 is going to charge $35 per hour, and that they're going to add a $25 travel charge. Now notice this per. That's going to be very important. That tells us it's going to be $35 not just once, but for each hour. So because we're looking for the amount of time, how long must a service call be, we're going to take hours and use that as our variable. So A1 charges $35 per hour times however many hours the service call is. And in addition, they're going to add $25 just for driving out there. Good Guys Plumbing Repair charges $40 per hour, and they have no travel charge. So this means for Good Guys, it's going to be $40 times the number of hours that the service call takes, plus no travel charge. You can just leave this part off if you like. Since all of our constants are on one side of the equation, we're going to put variables on the other side. So, in order to get rid of that 35x and take it to the other side, we see that it's positive here, so we're going to subtract it. That cancels it out. And what you do to one side, you have to do to the other. So that leaves us with 5x, and we'll bring down the $25. So we want to get the x all by itself. So to do that, because we're multiplying by 5, we're going to do the opposite and divide by 5. And what you do to one side, you have to do to the other. So that just leaves us with x, and 25 divided by 5 is 5. So the service call has to be 5 hours. So here we have a model, and first we have to figure out what this model represents. Here we have 1, 2, 3 x's and 1, 2, 3 negative constants. Here we have 1, 2 negative x's and 12 positive constants. So we have to derive an equation from this. We'll keep the equal sign directly in between them. And then let's take a look. Here we have 3 times some value x. Here, whatever amount that is being reduced by 3. On the other side, we have 1, 2 negative x's, and whatever that amount is, we're adding 12 to it. Now we have to solve. So a good strategy, if you're not sure what direction you're going to put all of your variables on, just think of swiping left on a crazy X. Here we have your X. We're going to move it to the left. Why? Because they are crazy. We're going to do the opposite of what we see here. And what you do to one side, you have to do to the other. Three plus 2, 5x. As for everything else, we're just going to bring it down. So now, the next step is going to be to move all of your constants to the other side of the equation. You want to get everything as far away from your crazy x as possible. So because we are subtracting 3, we're going to do the opposite in order to remove it from this side of the equation. And what you do to one side, you have to do to the other. Everything else we'll just bring down. So we're left with 5x equals 15. Well, to get the x by itself, we have to do the opposite of what we're doing in this equation. Since we're multiplying by 5, we'll divide by 5. This leaves x by itself. And then 15 divided by 5 is 3. So I hope that was helpful. Have a great rest of your day.